Hi, Professor. This is Karan, and I'll be doing the second question of homework 10. So the second question, it is there are different processes given, and we need to define them and explain them. The first process that has been given to us is the white sense stationary process, is a WSS process. So in a white inspiration process, that is, it is for a random variable, any random variable xt over the time interval from over any time interval that is 0 to infinity or minus infinity to plus infinity for time interval. If the mean is constant at at any time taken, and the autocorrelation function at time t1 and t2 is a function of tau, that is t1 minus t2, when it's defined as an White-Stein stationary process. So yes, so mean is constant and our t1 t2 is a function of t1 and t2. Now the second process that I need to explain is an independent increment process. An independent increment process is for if for a non-overlapping interval, that is for t1 to t2 and 3t to t4, or if these two are non-overlapping in increment, then the probability of event occurring in t1 to t2 and event occurring in this case we have taken a, so I'll explain with a. So event occurring in time a to b and in time C to D, E should be independent. That is, probability of this and this union this should be probability of events occurring in A and B into probability event occurring in C and D. So if these are independent, then said to be an independent increment. And if an process is independent increment, then has to be an uncorrelated increment where it is same for but the instead of probability is the expected value. So if as an independent increment, it has to be an uncorrelated increment also. The third process is Markov process. Markov process is nothing but it states that the future of a process doesn't depend on the past inputs. It's, is the past influence does not influence the past input do not influence the future but the condition is that the present input should be known. So if we know a present input, then the future only depends on the present input and does not depend on the past input, and the past input doesn't influence the output. So that's Markov process. The fourth process is a normal process. A normal process is a Gaussian or normal or Gaussian process is the process when at xt1, the process when a random variable xt at time t1 t2 t3 at all the time from minus infinity to plus infinity are jointly normal. Well, then the process is said to be a normal process. So yes, so it is. And the covariance, yeah, so these are the basic properties of normal process. So basically at all a normal process should be jointly normal at all time, that is t1 t2 t3. At any time we see, at any time we observe the normal process, it should be jointly normal with the past and the future normal process. So that's the yeah, right, that's normal process for you. So and also it's, yeah, non-plus is completely determined in terms of mean and autocorrelation, and yeah, it can also be defined completely if we know the mean, autocorrelation, and the autocovariance of a or autocovariance. So that's the normal process. Now the fifth process that we'll be doing is strict sense stationary. As we did earlier for a white sense stationary, over a time from minus infinity to infinity, a random variable xt is said to be a strict sense stationary if all is mean, if the joint density function at time t1 is same as joint density function at time t2, or you can at any time joint density function should be same is equal to the joint density function at some other time. So the joint density function should not vary with time. So if that condition implies, then it's said to be a strict sense stationary. And if a process is strict sense stationary, it has to be a wide sense stationary. And but a process being wide sense stationary does not imply it will be a strict sense stationary. But if a process is wide WSS and normal both, then it has to be a SSS always. So that's relation between normal SSS and WSS that we have learned till now. So the sixth one is a white noise. White noise is nothing but if we draw in a graph, white noise would be nothing but there's a white noise here occurring. That's the white noise for you. That's there's a noise, very random thing. So it is defined by nothing but it is such that the mean of a random mean is zero. Mean is of a white noise is always zero, and the autocorrelation function is q t1 and lambda t1 minus t2. So it is a process such that its values are different at times xt1 and xt2 are nearly independent. Actually, they are uncorrelated. They are they are not always independent time at this t1 and this, but they are uncorrelated. That is, their expected value is always independent. So that's white noise, and the last is nothing but mean ergodic. Is an ergodic process is nothing but when a process xt can be determined by if you have single sample and on basis of the single on if you have a single sample on basis of the single sample your entire process can be determined as an ergodic process. The process is said to be mean ergodic when your when for a time t interval when your process between time t1 and t2 when this basically when this condition satisfy where mean is a constant. So when the or in MS the mean square sense you can say that E minus is equal to 0. So when these conditions satisfy for an ergodic process, said to be a mean ergodic process. Thank you.